All right, guys, we're going to continue with Chapter 2. We're going to discuss Section 2.4, which is solving multi-step inequalities. So we're just doing exactly what we're doing, but we're going to look at a little bit more difficult examples here in this section. We'll look at an open middle in class. Let's look at example 1. So you can see it's the same exact idea as what we've been doing, except now there's going to be a couple more steps involved. But you're just solving an inequality the same exact way that you would solve any equation. So we want to get that variable by itself. So you want to think to yourself, okay, where's my variable? Here's the y that I want to get by itself. And then just use inverse operations to get that y by itself. So leave what's attached to the y to the end. Start by subtracting 7 on both sides. Now you've got y over negative 6 is less than 2. We've got division with our y values here, so in order to undo division, we're going to multiply both sides by negative 6. Multiply both sides by negative 6. Key thing to remember, same thing applies here. When you multiply or divide by a negative, don't forget to flip the sign. So remember, you have to flip your inequality sign here because we're multiplying by that negative 6 here. So we're going to end up getting y is greater than negative 12. There's our solution algebraically. It's asking us to graph this solution as well. You can see down here we've got a number line. So like I always said, I always put 0. 12 would live down here. Negative 12 would live down here. I've got an open circle because it's just a greater than symbol. So I'm going to have an open circle at negative 12, which means negative 12 is not a solution. Y is greater than negative 12. So I'm shading this way. And everything greater than negative 12 is a solution to our inequality. Second example here. Start by adding 4 to both sides. Add 4 to both sides. 2x is greater than or equal to 12. Divide by 2. And you're going to get x is greater than or equal to 6. We didn't multiply or divide by a negative, so we're not flipping the signs here. Graph our solutions, negative 6 down here, positive 6 down here. Close circle because we have greater than or equal to. We've got that equal to symbol there. And we're going to shade to the right, meaning that any value that is greater than or equal to 6 is a solution to our inequality. So we solve inequalities the same way we solve equations. We'll look at the try these in class. Example 2 now. So now we've got the same thing, except we've got variables on both sides. That's perfectly okay. Again, we solve it in the exact same manner that we solved an equation. So let's get our variables, collect them on the left-hand side. So I'm going to subtract 2x from both sides. I've got 4x minus 5 is less than 11. Add the 5, add the 5. 4x is less than 16. Divide by 4. And you're going to get x is less than 4 as your solution. So again, solving an inequality is the same exact way as solving an equation. There's really no difference between this inequality symbol and an equal symbol. Only thing you have to remember is if you end up multiplying or dividing by a negative, we've got to take care of that issue. 0's here, negative 4 lives down here, positive 4 is here. We've got an open circle, and we're shading to the left because it's a less than. So anything down below here, below 4, is a solution to our inequality. Two more. We're kicking it up a little bit more challenging inequalities for us to solve here. But again, we go about doing it in the same exact way. One thing I want to make note is you'll notice when I'm solving all of these inequalities, I like to collect my variables on the left-hand side. The reason I'm doing that is it makes it easier to graph. I can just use that inequality symbol sort of as an arrow to know which way to shade. First step here, I need to distribute. So now I've got 8x minus 3 is greater than 8x plus 12. Subtract 8x from both sides. Something weird happens here. Special cases. Make note of these. These are the ones that might give you trouble. We subtract the 8x on both sides, and it ends up canceling here as well as canceling over here. So we've got cancellation on both sides. And now we're just left with a statement that says negative 3 is greater than positive 12. We have to know our symbols. This is greater than. This is a case in which we have a false statement, okay? This is not true. Negative 3 is not greater than 12. This is false. So in this case here, our solution is no solution. There is no value of x that I can plug into our original equation that will ever make this true. Okay, nothing can be plugged in there to make this true. So there's no solution. There's nothing to graph on our number line. There's no value of x that will make that inequality true. Let's look at our second example. We have to distribute on this side. We're going to get 10x minus 2 is less than or equal to 7 plus 10x. Let's collect our x's on the left-hand side. So we'll subtract 10x here, and then we'll subtract it on our left side as well. It's going to cancel here, and it's going to cancel here. So once again, we have cancellation on both sides, which means we're going to have one of our special cases. This time we have negative 2 is less than or equal to 7. This is a true statement. So that statement is true. In this particular case, when we have a true statement, it's the opposite of no solution. Our answer is infinitely many solutions. Or all real numbers. What does that mean? That means any value in the world that you plug in for x will make this true. Everything is a solution. So every value on the number line is a solution to this inequality. Okay, so you have your two special cases here. The one where we end up with a false statement in our inequality, and then we have no solution. And then the other where we end up with our true statement in our inequality, and we have either infinitely many solutions or all real numbers. That means exactly the same thing. All right, so we'll look at some examples in class as well as the real world example here. But you have to just keep in mind solving an equation, or solving an inequality rather, is just the same exact process as solving an equation. Just remember those special cases that we talked about here when you have cancellation of your variables on both sides. Good luck, and I'll see you in class.